welcome back. Today we're going to be talking about graphing systems of equations and inequalities. Let's start with equations. So when we're going to use graphing to solve systems of equations, here are the steps that we need to follow. First, we've got to put each equation into slope-intercept form. Then we'll graph the equations and we'll find the intersection of those two lines. When the intersection of those two lines is, that is our solution. So let's now take a look at example A. So here we are at example A, and it says solve x and y and write your answer as an ordered pair. So again, we're going to use graphing in this particular case. So we're going to graph our two equations, which happen to already be in slope-intercept form for us. And then we'll see where those lines cross, and where they cross and intersect, that's going to be our solution. So our first line is going to be 4x plus 3. So we're going to go ahead and put a point at 3 because that's our y-intercept. Then we're going to go up 4 over 1 or down 4 over 1, depending on how we look at it. So down 1, 2, 3, 4 over 1. Down 1, 2, down 1, 2, 3, 4 over 1. All right, so we can see that we've got our line there. So we're going to go ahead and make our line all the way through the graph. Remember that we don't know where the other line is going to cross. So we have to make sure that we've got a line all the way through the graph so that we cover any place that it would cross. All right, now we're going to go ahead and graph our other line, which is y equals negative x minus 2. So we've got our y-intercept here at negative 2, and we're going to be going down 1 over 1, down 1 over 1, or up 1 over 1, or up 1 over 1. Up 1 over 1. There we go. Up 1 over 1, up 1 over 1. All right, so now we've got a line there. So we're going to go ahead and draw our line all the way through our graph. And then we're going to look for where they intersect. So we can see that they are intersecting right here at negative 1, negative 1. So this is going to be our solution. So all we have to do when we use graphing is we're going to take our points and find where the lines cross for our intersection solution. Now let's take a look at example B. So here we are at example B, solve x and y, write our answer as an ordered pair. Again, we've got two equations there, but one of them is not in slope-intercept form. So we can graph the first one. Let's do that now. So we've got a y-intercept of 2, and we've got a slope of 5/4, which is going to be a little challenging on this graph, but I think we can handle it. It's going to be positive 5/4, but we can't go up 5, so we'll go the other direction. So down 1, 2, 3, 4, 5 over 1, 2, 3, 4. And we've got, well, only 2 points, but that's all we need to do for our graph. All you need is 2 points so that you can connect with a line. So we've got our line here all the way through our graph with a straight line. So now the next thing we need to do is turn that other equation into slope-intercept form. So we're going to do that by subtracting 5x on both sides. So we'll subtract 5x there. We've got negative 4y is going to be equal to negative 5x. Then we're going to divide both sides by 4, or negative 4. Divide both sides by negative 4. These are going to cancel, leave me with y, and y equals negative divided by negative is a positive, or positive 5/4 x. Now, we don't have a y-intercept, so that means our y-intercept is going to be the origin. So we know we're going to be starting here at our origin, and we're going to be, again, going up 5 and over 4. So up 5 and then over 4 is this direction here, or we can go down 5 and over 4. So then we got our point here, and we're going to go ahead and connect our points with a line all the way through the graph and arrows on the end, and well, we can see here that these lines do not cross. They do not intersect. They don't have a point where they come together. And we can tell that because they have the same slope, which means if they have the same slope, they're going to be parallel lines. Parallel lines are not going to intersect. So in this case, we have no solution to this particular system, or empty set. Now let's take a look at graphing inequalities. So now we're going to talk about how we can solve a system of inequalities using graphing. So each inequality needs to be in slope-intercept form, just like they were for the equations, and graph the inequalities. Remember, we've got a shade because we've got an inequality. Then we'll find the intersection of the two lines. The intersection of the line is the solution, but only if both lines are solid. If one of the lines is dashed, that will not work. Points must be in all of the shaded regions at the same time in order to be considered solutions. So now let's take a look at the next example. Here we are at example C, and it says solve x and y, write 2 solutions for this system. So we're going to write 2 solutions when we're done. So it says y is less than negative 3/2 x minus 2. So good news, those are both already in slope-intercept form. So I'm going to go ahead and write the first one. So I've got negative 2 is my y-intercept there, and I'm going to be going down 3 over 2. So down 3 over 2 for 1 point here, and I could go the other direction. So up 1, 2, 3 over 1, 2 for another point on my line. So now that I've got those points on my line, it seems that I'm going to have a dashed line because I have no less than or equal to sign. All right, and I've got arrows on the end. So I've got to figure out where I need to shade. So you can use any point to do that. I'm going to use 0, 0, because if I get 0 times x, negative 3/2 times 0 is 0. So then I end with 0 is less than negative 2. That is not a true statement. So I'm going to be shading the area that doesn't have 0, 0 in it. All right, and I'm going to leave that here. Now I got to go ahead and graph my other line and shade. So I've got y is less than 3x plus 3, or less than or equal to. So I'm going to have a solid line there. So I'm going to go ahead and put a dot here. I can't go up 3, but I can go down 3. So down 1, 2, 3 over 1, down 1, 2, 3 over 1. All right, there we go. We got our line. This time it's going to be a solid line all the way through. So we've got a solid line all the way through. Not our straightest line, but we did the best we could. All right, so now the question becomes, where do I shade with this one? So again, I'll use 0, 0. So this time I end up with 0 is less than or equal to 3, and that is a true statement. So I'm going to be shading with the 0, 0 in this particular case. So shading everything with the 0, 0 in this particular case. Shade, 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 shade. All right, so now we need two solutions. Now, we can't pick where they intersected because one of these lines is dashed, which means that is not a solution to that one because it can't be less than or equal to, it can only be less than. So I have to pick points where they are both in the shaded region. So our shaded region here, I'm going to be coloring blue. So anything inside this blue area where it's shaded by both of the lines, okay, so both lines are shaded in that area, that is a solution that we can pick. So there are lots of numbers there. For example, -1, -5 works. So -1, -5 works because it is inside both the areas of the shaded region. All right, we also have -1, -3. That also looks like it works because it's inside that shaded region. There's almost an infinite number of the numbers that we can use here because we can go decimals, we can go fractions, but as long as they're inside all of the shaded regions, they will be solutions to this system. Now let's take a look at the last example. All right, here we are at example D, and it is a doozy as we're going to solve for x and y, and we're going to write two solutions to the system, but we've got 3 inequalities. So we've got to go ahead and graph all 3 of them. We've got y is greater than -1, so the good news is that's just going to be a horizontal line at -1. It's going to be a dashed line because we've got less than or greater than only. We don't have a equal to sign, so we've got a dashed line there, and we've got some arrows. So now we have to test. We're going to use 0, 0. Is 0 greater than -1? It is. So we're going to be shading everything above that line. This is shading just a little bit so we can see what we're working with later. So that will be good there. Okay, now we're going to go ahead and graph the next one, which is y is less than or equal to, no, just less than -2x minus 3. So we know -3 is going to be our intercept. We're going to go down 2 over 1. So down 2 this way over 1 this way. So we got that. And then we're going to go up 2 this way, and then we're going to go 1, 2 this way. All right. And again, we've got a dash line here because we've got just less than. I'm going to do one more. So up 1, 2 over 1. Give myself a better chance at drawing a straight line here. All right. So I've got a dash line that I'm going to go with. Dash, 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 dash. There we go. Arrows on the end. All right. Now we got to figure out where we're going to shade it. So that's going to be 0. So is 0 less than -3? No, it's not. So we're going to be shading this direction. Okay, so not true there. So everything over here gets shaded. All right, starting to become a little bit of a mess. And then the last one we need to graph is y is less than or equal to x plus 4. So in this case, we are going to have a solid line. So we've got x plus 4. So plus 4 is going to be our y-intercept. X is just 1x. So that means up 1 over 1 or down 1 over 1. Or down 1 over 1. All right, and we're going to have a solid line there. So let's go ahead and get that solid line going. All right, and we're going to have arrows on the end of that. Okay, now we've got to figure out where we're going to shade with that. So 0 plus 4, is 0 less than or equal to 4? Yes, it is, so that's true. So we're going to go ahead and shade everything below that line, so that's going to give us the 0. All right, now this looks like absolute chaos, and that's because it is. So we have to figure out where our points are going to be that are going to make this inequality true. Now this is a little difficult, but we can get it done. It's going to be where all of the lines cross. So where those shaded regions for all of them are. So that's going to be this little triangle here that we're going to kind of go over in black. All right, so in this triangle here is where all of the lines have crossed. Okay, so this section with the black triangle is where all 3 lines have intersected and made a shaded region of some kind for it. So as long as we pick any of the points inside that shaded region, we're going to be okay. So it's a little bit hard to see, but it looks like we might be going with fractions here as our best friend. So I can see that -3 is right in the middle of that shaded region. So I'm going to go with -3 for my x. I can't go up to 1 because that seems like it's like outside of my triangle. So I'm going to go up to 1/2. Okay, again, we can have fractions, that's okay. And then I'm going to go down from -3, and it looks like I'll just go down -1/3, because again, we don't have to have, we can have rational numbers. We don't have to have integers as our answers. These are solutions because they fall inside that shaded triangle where all 3 lines intersect. Of course, there are other ones that fit here. Any decimal, any fraction that's inside there works as well. And that brings us to the end of this question. It also brings us to the end of the set of notes and this video. If you like this video, go ahead and throw say thumbs up. If you love this video, go ahead and throw say sub, and we will catch you in the next one.